Hello and good day everyone. Welcome back to my YouTube channel. This is Sir Marcy and our lesson for today is all about rationalizing the denominator of a radical expression. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. How to simplify radical expressions. In my previous video, I already discussed how to simplify radical expressions. Radical expressions are in simplest form if it has the following conditions. Number 1, no perfect square factors other than 1 in the radicand. Let's say we have square root of 50. Square root of 50 is not in simplest form or not yet simplified. Number 2, we have no fractions in the radicand. Let's say we have square root of 36 all over 25. Still, this one is not in simplest form. These two are already discussed in my previous video. For today, we're going to discuss no radicals in the denominator of a fraction. Let's say we encounter this kind of problem, 1 all over square root of 5. This is still not in simplest form. What we're going to do in this example is we're going to rationalize. Another way of simplifying radical expression is through rationalizing the denominator of a radical expression. A radical expression is not considered to be simplified when its denominator contains radical. The process of rewriting the radical such that the denominator will not contain any radicals is called rationalizing the denominator. To rationalize a monomial denominator, we need to multiply an appropriate expression so that the result is a perfect nth root. Let's try to solve some examples. Let's say we're going to rationalize a square root of 7 all over a square root of 3. The first thing that we're going to do is to multiply it by square root of 3. Then we multiply square root of 7 times square root of 3. The answer is square root of 21 all over square root of 3 times square root of 3 is equal to square root of 9. Then we simplify. We know that square root of 9 is 3. So we now have square root of 21 all over 3. The goal is simple. We need to get rid of the radical in the denominator. So that is why our answer here is square root of 21 all over 3. This is now in simplest form. Let's try to answer number 2. If we have square root of 2 all over square root of 5, again we multiply this by square root of 5. Then we multiply square root of 2 times square root of 5. The answer is square root of 10 all over square root of 25. Then we simplify. We know that square root of 25 is 5. Therefore, our answer here is square root of 10 all over 5. Notice that the denominator now is free of radicals. Okay, let's try to have some more examples. Let's say we have 8 times square root of 1 all over 3. We can rewrite this as 8 times square root of 1 all over square root of 3. Then we rationalize, meaning we're going to multiply both sides by square root of 3. Then we now multiply 8 times square root of 1 times square root of 3. The product is 8 times square root of 3 all over square root of 3 times square root of 3. The answer is square root of 9. And then we simplify. We know that 9 is a perfect square and it has a square root. The square root of 9 here is 3. We now have 8 times square root of 3 all over 3. So this is now our answer. And our answer now is free from radicals, especially the denominator. Now let's try to have some more examples. Let's say we have square root of 7 all over square root of 2 times square root of 5 all over square root of 3. So we multiply again. This is now square root of 35 all over square root of 6. Then we rationalize, meaning we're going to multiply both sides by square root of 6. So the product of square root of 35 times the square root of 6 is square root of 210 all over square root of 36. Now before we arrive with final answer, let's try to check if 210 is still reducible to lowest term. So by prime factorization, we have 21 times 10, and this is 7 times 3, and this one is 5 times 2. Notice that these are all prime numbers, so that means square root of 210 is already in simplest form. So that's square root of 210 all over. We know that 36 is a perfect square and it has a square root. That is 6. So this is now our answer. And our answer now, especially the denominator, is free from radicals. Alright, let's try to answer these last two remaining problem. Suppose we're going to simplify and rationalize square root of 63 all over square root of 50. Again, we can rewrite this one as square root of 63 all over square root of 50. Let's try to simplify first the numerator and the denominator. Let's see if we can simplify them. First is we write the factor of 63. We know that 63 has a factor of 9 times 7. We know also that 9 is a perfect square, so we can rewrite this now as square root of 9 times square root of 7 using the product rule for radicals. Whereas 50, it has a factor of 10 times 5. That's also 25 times 2. If we're going to examine, we're going to find a perfect square, and that is 25 times 2. So we write it square root of 25 times square root of 2. Then we can simplify this. Square root of 9 is 3, square root of 7, all over. Square root of 25 is 5, square root of 2. Then we will rationalize. We multiply both sides by square root of 2. So we now have 3 times square root of 7 times square root of 2. The product is 14 or square root of 14 all over. We have 5 times square root of 2 times square root of 2, which is equal to 4. We know that 4 is a perfect square and it has a square root. So our answer here now would be 3 times square root of 14 all over 5 multiplied to 2. So the answer now here is 3 square root of 14 all over 10. Let's have our last example. If we have square root of 16 all over 3, we know that square root of 16 it's a perfect square. That's why we will write 4 all over square root of 3. Then we rationalize, multiply both sides by square root of 3. Then our answer now here is 4 square root of 3 all over square root of 9. Square root of 9 is equal to 3. So 4 square root of 3 all over 3. And again, our answer is free from radicals, especially in the denominator part. So this is what we're going to do in rationalizing the denominator. That's all for now. I hope you learned something new today, and I hope to see you soon. Goodbye.